group projects. In this video, we are going to explain about detecting and characterizing extremist reviewer groups in online product reviews. Introduction. The goal of the project is to find and characterize extremist reviewer groups in online product reviews. We gathered feedback from the Amazon product review site to extract groups they employed frequent item set mining over brand similarities. They created a supervised model based on features to classify prospective groupings as extremist entities. The initiative delves into the activities of such groups in order to better understand the mechanics of brand level opinion falsification. The investigation discovered that there are a large number of certified reviewers who express extreme sentiment, which leads to ways to evade the existing measures in place to prevent Amazon from offering unofficial incentives. Objective. The objective of this project is to create a system that can recognize and characterize extremist reviewers groups in online product evaluations. To train the model for detecting extremist reviews, the project employs LSTM, a type of RNN algorithm. For training the LSTM model, the Amazon product reviews dataset is used. To prepare the reviews for input to LSTM, pre-processing techniques such as NLTK for cleaning and TF-IDF for numerical conversion are used. The trained LSTM model can then predict if a particular input review is extremist or moderate, helping to identify and analyze extremist behavior in online product evaluations. Requirements. The requirements of the project are hardware requirements and software requirements. In hardware requirements, we have operating system Windows only, processor i5 and above, RAM 4GB and above, hard disk 20GB and above. In software requirements, we have Python IDE with 3.7 version. Methodology. To implement this project, we have designed the following modules. The first module is Upload Amazon Dataset. This module involves obtaining a dataset from Amazon that contains product reviews. The dataset have attributes like review text, reviewer information, product details, ratings, etc. The dataset will be used for training and evaluating the RNN recurrent neural network algorithm. Second module is data pre-processing. Before feeding the dataset into the RNN, data pre-processing is required. This step involves cleaning the data, removing irrelevant information, handling missing values, and converting test data into numerical representations. Text data may also undergo tokenization, stemming, and lemmatization to standardize the words and make the input consistent. Third module is Run RNN Algorithm. The RNN algorithm is employed for sequence data analysis. In the text of online product reviews, the RNN can analyze the sequential nature of reviews and capture dependencies between different parts of the text. The model takes the pre-processed review text as input and learns to predict certain characteristics or labels associated with the reviews. Fourth module is RNN metric graph. After training, the RNN algorithm performance evaluation is crucial. Metrics like accuracy, precision, recall, F1 score can be computed to assess the model's performance. The RNN metric graph visually represents how these metrics change over epochs during training and can help identify the point of convergence and potential overfitting. Fifth module is confusion matrix graph. A confusion matrix is used to evaluate the performance of a classification model. It shows the true positive, true negative, false positive, and false negative values for each class. The confusion matrix graph provides a visual representation of the model's performance in predicting extremist and non-extremist reviews, allowing for a better understanding of classification accuracy and potential biases. Sixth module is Predict Extremist Group. Using the trained RNN model, this module predicts whether a given product review belongs to an extremist reviewer group or not. Extremist characteristics can be identified based on certain keywords, sentiment, or behavioral patterns within the review text. The model can identify patterns that are indicative of extremist tendencies or aggressive behavior. Execution. For the execution of the project, we need to open the code folder. This is the code folder. This is the dataset folder. To implement this project, we have used Amazon Reviews dataset. Importing this dataset contains the information of dog ID, label, review test, etc. This is the model folder. This folder contains pickle files stored which contains algorithm information. These pickle files can be loaded into the project code during runtime to utilize the train models. This is the main code file. This is run.batch file. Instead of executing our project in the command line interface, we have created Windows batch file to execute the project. Double click on run.batch file. So this is the graphical user interface which we have created using Tkinter library in Python. Using this GUI, we will interact with the project. Click on Upload Amazon dataset to upload the dataset. Select Amazon reviews and open. So here we can see that the dataset is loaded and dataset loaded with reviews and contains special symbols and stop words like the, and, or, where. And we can remove such words by pre-processing reviews and then split dataset into train and test by clicking on data pre-processing. So here we can see that the dataset is pre-processed and the dataset contains the total reviews of this much, and the dataset is split into training and testing. Now click on Run RNN algorithm to train RNN and get its accuracy. After training RNN algorithm, we will get the precision, recall, F1 score and accuracy of RNN. And this is the RNN accuracy and loss graph. X-axis represents iterations and epoch, Y-axis represents accuracy or loss. And the green line represents the accuracy and red line represents the loss. So we can say that with each increasing epoch, accuracy got increased and loss got decreased. And accuracy reached closer to 100%. Close the graph. Now click on Run SVM algorithm to train SVM and get its accuracy. So here we can see that after training SVM algorithm, we got the accuracy, precision, recall, F score of SVM. And this is the confusion matrix of the SVM algorithm. Here x-axis represents the predicted class and y-axis represents the true class. And the yellow color represents the correct prediction and blue color represents the incorrect prediction. Close the graph. Now click on Run Decision Tree algorithm to train decision tree and get its accuracy. After training decision tree, we will get the accuracy, precision, recall, F score of decision tree. And this is the confusion matrix of decision tree. X-axis represents the predicted class and y-axis represents the true class. Here light green and yellow color represents the correct prediction and blue color represents the incorrect prediction. Close the confusion matrix graph and click on Run Random Forest algorithm to train random forest and get its accuracy. So here we got the accuracy, precision, recall, F score of random forest. And this is the confusion matrix of random forest. Here x-axis represents predicted class and y-axis represents true class. And the light green and light yellow color represents the correct prediction and blue color represents the incorrect prediction. So correct prediction is moderate and incorrect prediction is extremist. Close the graph. Now click on RNN matrix graph. This is the RNN matrix comparison graph. So here we can see that x-axis represents the predicted class and y-axis represents the true class. And on x-axis we have the metrics like accuracy, precision, recall and F score. And on y-axis we have moderate and extremist. Now close the graph. And now click on confusion matrix graph. So here we can see that x-axis represents predicted class and y-axis represents true or original class values, and in above the light green and yellow color represents the correct prediction and blue color represents incorrect prediction. So here we can see that we are having two extremists. Now we'll close the graph. Now close the graph and then enter some reviews by copying from textreviews.csv file, and then click on predict extremist group to predict reviews as extremist or moderate. So here I'm pasting the review which I have copied from the test reviews, and now click on predict extremist reviewer. So here we can see that the review which I have just pasted is predicted as moderate. So the review is, when least you think so this product will save the day, just keep it around just in case you need it for something. So this review is predicted as moderate. So now we will type another review. So we will get the reviews from the data set, and in data set we have test reviews. So from the test reviews we need to copy the review. So I have copied the first review, and now we just need to paste it in the input reviews and click on predict extremist review. So here we can see that the review which I have pasted is predicted as extremist. So in this way we can test all the reviews which are present in the test reviews and just paste it in the input review and click on predict extremist reviews. We'll get to know whether the review is moderate or extremist. Now click on all algorithms graph. So this is the all algorithms graph. On x-axis we have the algorithm's name, and on y-axis we have the values. And here each algorithm is having different metrics, and each matrix is represented by a different color. So we can see that accuracy is represented with blue color, F1 score with orange color, precision with green color, recall with red color. Now close the graph, and the final conclusion of the project is: the project successfully detects and characterizes extremist reviewer groups in online product evaluations using LSTM, a form of RNN algorithm. The LSTM model is trained to distinguish between extreme and moderate evaluations using the Amazon product reviews dataset. The model's performance is improved by using NLTK for data cleaning and TF-IDF for numerical conversion. After training, the LSTM model can correctly determine whether a particular review is extremist or moderate. The project contributes to a better understanding and management of potential extremist actions in e-commerce platforms by providing a valuable tool for spotting and accessing extremist behaviors in online product reviews.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.